For most of human history, the open ocean has appeared as an endless, desolate expanse, a quiet, unchanging horizon stretching out in every direction. But to see how land is born, we have to look thousands of feet below that surface. This diagram shows Earth's crust broken into massive pieces called tectonic plates. Deep underwater, these enormous slabs of rock are constantly shifting, and when they slowly pull apart, the ocean floor cracks open. Beneath that gap, extreme pressure forces molten rock, or magma, up from the Earth's mantle and into the newly formed fissure. When thousands of degrees of boiling magma slam directly into freezing, high-pressure deep sea water, the reaction is incredibly violent. The molten rock cools in seconds, solidifying and cracking into a dense new layer of stone. Far away from human eyes, in the pitch-black abyss, this continuous stacking of fresh stone lays the physical foundation for a new terrestrial empire. Building a submarine mountain requires an immense scale of time. It takes thousands of separate, unobserved eruptions occurring repeatedly over millennia. With every breach of the seafloor, fresh lava spreads outward, solidifies into heavy rock, and stacks the landmass higher and higher into the water column. Eventually, this growing peak approaches the sunlight. The ocean begins to churn. The water boils, and waves crash against a hidden obstacle just below the surface. Then, the growing mountain finally breaks the surface. Thick ash, steam, and volcanic gases vent directly into the open air. At the new coastline, the cold ocean and thousands of degrees of hot lava collide head-on, creating a continuous, explosive clash of elements. The powerful waves shatter the brittle, newly formed stone, actively tearing the coastline apart. Yet simultaneous streams of fresh lava pour down over the cliffs, replacing the lost rock and pushing the landmass further outward. This intense geological warfare can wage for decades. The constant push and pull between the ocean's erosion and the volcano's output ultimately dictates the structural shape of the land. When the eruptions finally pause, what remains above the water is completely sterile. There is no dirt, no fresh water, and no organic life. It is a harsh, toxic expanse of gray ash and hardened stone. This smoking expanse provides the essential, sterile surface required for nature to begin its next epoch. Life must now find a way to reach a fiery, isolated void in the middle of the ocean, separated from the nearest mainland by hundreds of miles of deep water. The first invaders arrive by chance. Strong winds carry microscopic spores and seeds across the horizon, while ocean currents deliver floating rafts of plant debris to the rocky shores. Next to arrive are the very first biological pioneers. Flocks of seabirds arriving from distant continents use the barren ridges as a mid-ocean refuge, depositing seeds and nutrient-rich waste directly onto the stone. This kicks off a crucial process called primary succession, the mechanism of exactly how life establishes itself in a previously lifeless area. As this diagram illustrates, early vegetation forces its roots into tiny cracks, physically breaking apart the weathered volcanic stone. When those plants die, their decaying matter mixes with the fractured rock to synthesize the island's very first layer of true, dark soil. Through this slow, deliberate invasion by wind, water, and wing, a towering pile of sterile ocean rock has successfully transformed into the foundation of a living terrestrial kingdom. Centuries later, that same harsh rock holds a complex, self-sustaining ecosystem, complete with varied vegetation and carved streams. But this entire biological network rests squarely on the back of a sleeping giant. The volcano below remains a perpetual threat. A sudden return of molten rock and suffocating ash can incinerate forests and bury streams, resetting thousands of years of biological progress in a single afternoon. Because of this extreme isolation and cyclical destruction, these infant islands serve as invaluable natural laboratories. They allow modern researchers to observe exactly how an ecosystem constructs itself from absolute zero. Below the surface, every individual layer of hardened lava acts as a physical archive, Each distinct band of rock locks away a chronological record of the atmosphere, the climate, and the planet's deep time history. And as this specific island matures above the waves, the exact same invisible forces are already at work somewhere else. Earth operates as an eternal, dynamic creator, continuously reshaping its surface and writing new chapters of its own geological story.